Welcome to the FFcam video demonstration. You are going to see something here no one else will show you. A demonstration with live calculation times. This AVI has not been sped up or spliced together. This is all real time. Keep that in mind as we now demonstrate FFcam by Makino. We are using FFcam as it comes out of the box. FFcam requires a very brief setup at the beginning of a project to define the machine, the raw block size, and the material being cut. FFcam will utilize the material type and tool selection to provide automatic recommended speeds, feeds, step-overs, and step-downs based on 30 years of Makino best practices. You can easily add to the 240 tools and 40 holders provided in FFcam with your own tools. FFcam utilizes intelligent process models. These process models contain all the information required to create high-quality cutter paths. All the typical choices for a superior cam system are available for setting and changing, but not required. Creating your own unique intelligent process model is truly as easy as drag and drop. We have selected the initial roughing intelligent process model, selected a tool, and will now compute the first cutter path. You are already seeing how FFcam is the easiest cam software to learn and use on the market. FFcam will provide superior surface finishes, improved tool life, especially with its hard milling secrets, and dramatically reduced programming time. Imagine never having a machine sitting idle, waiting for a program. And if you have ever wanted to implement standard cutting practices, FFcam's intelligent process models will allow you to do that and become more profitable at the same time. The first cutter path took 28 seconds to compute, not only the cutter path, but also to create the setup sheet and post the output for your machine tool. FFcam has a built-in post builder and works with all machine tools and controls, not just Makino's. I've selected a secondary roughing strategy from the intelligent process models. After selecting this, FFcam's simple top-down approach to making any modifications to the process leads me through my choices. This secondary process requires only 3 selections: a cutter from the database, a finish allowance, and whether we wish to use a stock model. To create your own process models, you would follow this same strategy. When you had altered a standard Makino intelligent process model, you would do nothing more than save it as your process name, whether for a single cutting strategy, a collection of strategies, or for a whole class of parts. Adding additional tools and holders is just as easy, and FFcam allows you to interference check up to 20 levels of the tool and holder. FFcam always knows where the stock is, which is why it's so exact and provides such a great surface finish with reduced tool wear. FFcam also works in 3+2 mode with all the same features and abilities, including knowing where the stock is, and programming in 3+2 is just as simple. We are now going to utilize a process model for picking out the corners, referenced as the contour corner. Once again, we will merely pick the intelligent process model for this strategy, and in this case select a 1mm ball cutter. We will also provide FFcam with a previous cutter used in this area and the desired finish allowance. While we do these simple tasks, let me provide a little more detail about what this cutter path actually does. In most systems, when you pick a corner, the system simply does a trace type cut that follows the radius. FFcam differs in the fact that we always try to maintain a constant chip load. We understand the remaining material, and we program for the cutter's ability. So when we get a chance to look at this cutter path, you will see that we take multiple steps in X, Y, and also in Z to step our cutter into the remaining stock to remove it more efficiently, which will provide you a better cutter life and a better finish. This contour corner cutter path took 28 seconds to create the setup sheet, calculate, and post the file for your machine. Notice as we take a closer look at the cutter path here, the multiple X, Y, and Z steps taken. This is one of the secrets to being able to hard mill effectively. we are now going to create a finishing cutter path. In FFcam, we have a few different intelligent process models that will work. But for this geometry, I'm going to select a contour scan. This style is really 3 different cutter paths in one. FFcam interrogates a geometry, and any surface that it finds that is less than 30 degrees, the system will create a scan type pass across this area. Any surface FFcam finds that exceeds the 30 degrees, the system will create a Z-level type finish. These 2 areas will overlap by default. The third portion of this strategy is called guide cutting. This feature will add extra passes to the scan feature when encountering a standing wall. These extra passes are like a racetrack, tracing the area, taking small micro steps as it gets close to the wall to avoid any chatter. As this cutter path calculates, let's take a moment to review. We are currently 6 minutes into this video demonstration, and the part is 1 step from being complete. We have already set up the machine, defined the raw block size, chose the machine to run on, and we've created now 4 cutter paths: a rougher, a semi-finish, a corner remachining pass, and this finish that it's calculating now. All, by the way, with a tolerance of 0.001 millimeters. There's one feature here I'd like to point out to you. The yellow curve that you see on the part is actually FFcam step down. We avoid stepping down the same area to avoid any witness lines left on the part. In this last cutter path, we are going to create one final corner picking pass. This is slightly different from the first style we used. This one is generally used for finish work. We set it up the same way as before by selecting the cutter that we will use, as well as the cutter that was previously used and its finish allowance. As this part displays, you will see we are still attacking the corners with multiple passes, but we remain on the part and walk through the radius. These 2 routines combine for an outstanding part. This part was completely programmed, calculated, and posted in just under 8 minutes. In closing, I would like to leave you with a few questions. Would any of these following make your shop more profitable? Programming time reduced by 25 to 70%. Outstanding surface finished and reduced bench time. Improved tool life. Hard milling strategies. A more efficient use of your current machine tools. It's hard to say no, but you're probably worried about your productivity loss while you learn FFcam. We will come to your shop on Monday morning. By Friday, you will have written several programs for your parts. You would have cut some number of those parts and be as productive, and likely more productive, than you were on Monday. Keep the shop running and get all the benefits.